All right, what's up, everybody? I want to talk to you about Snell's law and work a couple of problems. But before we do that, let's just kind of do a quick review about what happens when sound travels through an interface of two materials. Okay. So this is an interface. Okay, there's two different materials here. This is material one. Let's just say it's water. It could be anything. This is material two. Okay, and let's just say this is steel. Okay, so what happens when sound travels through this interface into this interface? All right, so we know that, let's just say, for example, this is water. Actually, that's bad. Let's say this is steel, and this is another block of steel, and they're perfectly pressed together so that there's no air in between them. Okay, so if sound is traveling in a straight direction this way to this interface, when it gets to this interface here, it's going to continue on in the same direction, and it's not going to change speed. It's going to go at the same speed. Now, let's say this was a different material, and it could be any material. Let's say this is water. Okay, so the sound is traveling through this interface here at some speed. Then it continues on in the same direction. When it gets into this interface, interface 2, it's going to change speed. Okay, the velocity will change. Okay. Now, sometimes it'll slow down, sometimes it'll speed up depending on the material, but it will change. Okay, unless it's the same material, the speed is going to change. Now, we need to establish a definition. So this line here, this is what we call the normal line. Okay, the normal line is basically a line that forms a 90-degree angle with the interface. Okay, so all the normal line is a line that forms a 90-degree angle with the interface. Okay, so why do we need the normal line? Because that's how we measure the angle of the sound. Okay, so if the sound is coming in at an angle, we measure it from the normal line, from here to here. So we say the normal line is 0 degrees. Okay, so if sound is traveling in this direction, it's basically 0 degrees because it's in line with the normal line, or it's parallel to the normal line. So that's a 0 degree line. Now, if sound is coming in at some other angle, again, we measure that from the normal line. And let's just say this is 15 degrees from normal. Okay? So we know that if sound is traveling in this direction, 0 degrees to the normal, okay, when it passes through this interface, it's going to go in the same direction. Okay, it's not going to change directions at all. All right? But if it's traveling at any angle other than 0 degrees when it gets to the interface here, it will not continue in on the same direction. It's going to refract or bend. It's going to change direction. Okay, it will either go a little bit towards the normal, or it will go a little away from the normal, depending on, what speed the second material is, but it will refract. We call this angle here angle 1, okay, or we might call it the incident angle, okay, theta I, theta 1 or theta I. We call this angle here, measured from the normal, theta 2, or it might be called theta R for the refracted angle. Okay, so what we have here, again, a couple different things we got going on. We have a material here, material 1, and then we have material 2. Okay, the rate at which sound travels through material 1 we call velocity 1, and the rate at which sound travels through material 2 we call velocity 2. Okay, and then we have our incident angle. Okay, and normally we call that theta 1. And then you have your refracted angle, and we'll call that theta 2. What Snell's law does, it tells us that there's a relationship between the ratio of the sine of angle 1 and the sine of theta 2 and velocity 1 divided by velocity 2. So it tells us that the ratio of the sine of the two angles is equal to the ratio of the sine of the velocities. Okay, so why is that important? It's important because if you know, basically this is an equation, and if you know any of the three things, you can solve for the fourth. All right? So it doesn't matter which three things, if you know any of the three things, you can solve for the fourth. All right, so let's see how this works. So basically what we're going to do here is we're going to solve 4 different problems together. And each time we're going to solve for a different variable. So we're going to do one problem where we sign for theta 1, one where we solve for theta 2, and then we're going to solve for velocity 1 and solve for velocity 2. Now the steps for doing all of these is exactly the same. Okay, so as long as you know the process and the steps, you can solve for any of these variables. Okay, so let's take a look at the first problem. Okay, so for this first problem, what we're going to do is I'm going to give you angle 2. So this angle here, I'm going to tell you is 22 degrees. Okay, I'm going to give you speed in this material. I'm going to say V1 equals 1.5. And I'm going to give you the speed in this material. I'm going to tell you V2 equals 2. Okay, and so what you need to solve for is theta 1. Okay, because we don't know what this is. And if we know any of the three things, we can figure out the fourth. Okay, so let's see how this works. The first thing I always do is just write the equation. Sine of theta 1 over sine of theta 2 equals V1 over V2. Step 2, plug the numbers into the equation. Okay, so sine of theta 1, I don't know this, so I'm just going to write sine of theta 1. That's the variable that I'm trying to solve for. Divided by the sine of 22 degrees equals V1, which is 1.5, divided by V2, which is 2.00. Okay? The next step is to cross multiply. So I'm going to multiply this by this, and then I'm going to multiply this by this. And when I do that, what I end up with is 2 times the sine of theta 1 equals 1.5 times the sine of 22 degrees. Okay, so now I'm almost there. Now remember, the variable that we're trying to solve for is theta 1, this. So we need to get this by itself. So this is an equation, and you know you've solved the equation when you get the variable by itself on one side of the equal sign. Okay, it's just like in algebra when we're trying to solve for x. The sine of theta 1 essentially is the x that we're trying to solve for. So to get it by itself, you have to get rid of whatever is with it on this side of the equal sign. And right now we have 2 being multiplied. So to get rid of the 2, you have to do the opposite of whatever operation is happening. So here it's multiplication. So to get rid of it, I need to divide. Okay, so I divide by 2, and this cancels out. But whatever you do to one side of the equation, you have to do to the other. So I divide this by 2. And then what you end up with is the sine of theta 1 equals 1.5 times the sine of 22 degrees divided by 2. Now, all we have to do now is put this math in our calculator. 1.5 times the sine of 22. Hit enter. Then divide that by 2. And when you do that, you get the sine of theta 1 equals 0.28, we'll say 1, I'm rounding degrees. Or I'm sorry, not degrees, 0.281. Okay, now this isn't an angle. We want to know the angle. What this does is this gives us the sine of the angle. And remember, a sine is just a ratio. So to figure out the angle, you have to do the arcsine function in your calculator. So you hit second sine to access that arcsine function, and you hit 0.281, hit enter, and you find out that the theta 1 is equal to 16.32 degrees. So this angle here is 16.32 degrees. Okay, so for this next problem, I'm going to give you angle 1. I'm going to tell you that this is 15 degrees. I'm going to give you the velocity of this material, okay, which is, I'm just going to say it's 200. Okay, so this is velocity 1. And the velocity of material 2, let's just say it's 350. Okay, this is V2. Okay, so what I need to figure out here is theta 2. I need to figure out what my refracted angle is. Okay, so again, first thing I do is I write out the equation. Sine of theta 1 divided by the sine of theta 2 equals velocity 1 divided by velocity 2. Now, I want you guys to go ahead and pause the video, work this out, see what you get, and then push play. Okay, so next step is to plug in the numbers into the equation. So the sine of 15 degrees over the sine of theta 2. Now this is the variable that I'm trying to solve for. Okay, equals 200 divided by 350. Okay, next step is to cross multiply. So I'm going to divide this by this. And then I'm sorry, I said divide, I meant multiply. And then I'm going to multiply this by this. All right, so what I end up with is 350 times the sine of 15 degrees equals 200 times the sine of theta 2. All right, now remember again, this is the variable that we're trying to solve for, so I need to get it by itself. In order to do that, it's being multiplied right now, I have to divide. So divide by 200, and that cancels out. Whatever you do to one side, you have to do to the other. Divide that by 200, and what you end up with is the sine of theta 2 equals 350 times the sine of 15 degrees divided by 200. So again, I just stick that in my calculator, 350 times the sine of 15. Hit enter, and then divide that by 200. Okay, what you end up with is the sine of theta 2 equals 0.453. I'm rounding again. Okay, so again, this gives you the sine, which is a ratio of an angle. We need to know what the angle is. So in order to figure out the angle, you have to take the arcsine function, 0.453, hit enter, and you find out that theta 2 equals 26.9, let's just say 4 degrees. Okay, so this angle here, theta 2, is 26.94 degrees. Okay, on this next problem, I'm going to give you angle 1, and I'm going to say this is 19 degrees here. I'm going to give you angle 2, and let's just say this is 45 degrees. All right, and then I'm going to give you velocity 2, and I'm going to tell you this is 5. So what you need to figure out is velocity 1. Okay, so go ahead and take a minute, pause the video, try to work this out on your own, see what you come up with. Okay, to solve this, again, I always write out the equation. I know it seems redundant, but I've learned when you do things in a methodical way, it increases your accuracy. Okay, so step 2 is go ahead and plug in the numbers. So the sine of 19 degrees divided by the sine of 45 degrees equals V1 divided by 5. And again, V1 is the variable that we're trying to solve for. Okay, so that's essentially our x. So what we need to do is cross multiply this by this and this by this. Okay, so let's do that. So I end up with 5 times the sine of 19 degrees equals V1 times the sine of 45 degrees. Okay, so now to get V1 by itself, I have to divide this side by the sine of 45 degrees. That cancels out. Whatever you do to one side, you do to the other. So divide this by the sine of 45 degrees. And what you end up with is V1 equals 5 times the sine of 19 degrees divided by the sine of 45. So again, we just plug this into our calculator. 5 times, 5 times sine of 19, enter, and then we're going to divide that by the sine of 45. Okay, and what you end up with is V1 equals 2.302. All right, so for this last problem, I'm going to give you this angle here, which is 5 degrees. I'm going to give you this angle here. I'm going to tell you that's 12 degrees. I'm going to give you velocity 1, and I'm going to say that equals 2. I want you to figure out velocity 2. So what's V2? Okay, again, go ahead and pause the video, work this out, and see what you get. All right, step 1, I'm writing out the equation. Step 2, plug in the numbers. Step 3, cross multiply. Okay, step 4, get the variable by itself, which is V2. So I'm going to divide each side by the sine of 5 degrees. That cancels out. Sine of 5 degrees. Okay, and what I'm left with is V2 equals 2 times the sine of 12 degrees divided by the sine of 5 degrees. Put this in my calculator, 2 times the sine of 12, and I divide that by sine of 5. Hit enter, and what you end up with is V2 equals 4.77. All right, so I hope you guys see that the steps are basically the same regardless of what you're solving for. I hope you also see this isn't very difficult. It just takes practice. Okay, so what I recommend is you just work these problems over and over and over again until you're sick of it and you know you've got it down. And, go back, rewatch the video if you need to. Pause it, work it, see if you got the right answer. And there's no secret to this, it's just repetition. So good luck. Bye.